Hello, Chem 2 students. Mr. Keister back with you again today. This is an additional video for Monday, October 12th, 2020, our scheduled 37th day of school for the fall semester. You should have already watched the video on today's lesson. It was quite short over noble gas configurations. And remember that assignment was due today. You were to finish the assignment you started yesterday. The assignment is due today by the dismissal bell. So make sure you have that done and turned in. Of course, if you're at home, make sure you have that submitted to me by the end of your regular scheduled class period as well. You should be working or have finished your Unit 3-1 exam review. And hopefully you have that done today and can check it before you leave. Otherwise, it'll be posted in the morning at 7 a.m., both here on the board at school and on Canvas on the answer keys page. I wanted to make this video separately from the lesson video. This is specifically talking about tomorrow's exam. So let's go back to the do nows and pick up with that. So let me advance the page here. So Unit 3-1 exam is tomorrow. It's a big one, folks. We have learned a lot in this unit, working our way towards the quantum mechanical model, which is the modern atomic model. There are 34 questions on this exam. 22 of them are multiple choice. On several of the multiple choice, you will be required to show equations and work, all right? So first, you are to know the 7 types of electromagnetic radiation. Of course, that would be gamma to radio, and their relative wavelengths in terms of where are the largest and where are the smallest. Their frequencies, same thing, and their energies. Study your EMR chart, the colored one, all right? We went over all that, how the EMR is set up via wavelength, via frequency, and via energy, all right? Make sure you know those trends as you work your way from left to right or right to left across that EMR spectrum. Know the 6 or 7, if we throw in indigo, colors of the visible spectrum and their relative wavelengths, frequencies, and energies. Again, this is on that same color chart, right? Remember, the visible spectrum is very narrow. We've opened it up down at the bottom of the page there. And again, make sure you know the wavelengths from left to right. Of course, violet's the smallest wavelength, around 400 nanometers. Red is on the other end, the far end. Its highest red is 750 nanometers. Make sure you know that. And then the others fall in between. I don't necessarily think you need to know the wavelength areas for the rest of the colors, but make sure you know the boundaries. All right, make sure you know them. And again, know the trend in regards to wavelength, frequency, and energy for the colors of the visible spectrum. Here are the like I said earlier, there'll be a few calculations on the multiple choice section. Here they are right here. Be able to perform basic calculations involving the speed of light equation and Planck's energy equation. So the speed of light equation relates the speed of light, frequency, and wavelength of any type of EMR. And Planck's energy equation relates frequency and energy, all right? Those equations are provided on the test, but you need to know how to use them, all right? Next, know the contributions of Planck, Einstein, Bohr, and de Broglie regarding the particle or wave theory of light, and Schrodinger, Heisenberg, Pauli, and Hund regarding the quantum mechanical model. A lot of names there. We talked about all of them. Make sure you know what their contribution was, all right? And finally, this is the big one. Know all the aspects of the quantum mechanical model, including all 4 quantum numbers, what they stand for, all right, what each quantum number tells you about the location and or motion of an electron. Remember, all 4 quantum numbers represent 4 different aspects of an electron's location or motion. What values each quantum number can have. Remember, each successive quantum number's values are dependent upon the value of the quantum number preceding it, starting, of course, with n, the principal quantum number. How many electrons can fit in an individual orbital? Hopefully we know that's 2, all right? Now, in an s sublevel, there's only one s orbital because there's only one value of m, the magnetic quantum number. But in a p sublevel, for example, in a p sublevel, there are 3 individual p orbitals. All right, px, py, pz for the 3 values of the magnetic quantum number m, -1, 0, and 1. Each of those individual orbitals holds 2 electrons, and so a p orbital or a p sublevel holds a maximum number of 6. All right, don't get those confused. All right, sublevel. Well, we just said that a p sublevel holds 6 electrons, an s2, a d10, and an f14, and so on. And how many electrons can fit in an energy level? Well, you could look at that several ways. I guess the quickest way would be is the shortcut is 2n squared. You could also look, if you understand how the diagonal rule works, if you look at it horizontally, that'll tell you how many orbitals are in, or how many sublevels are in each energy level, which would then tell you how many electrons are there if you just count them and add them up. Lot of questions regarding the quantum mechanical model. Quite a few. All right. Then 12 out of the 34 questions will involve filling out charts, performing additional calculations, and doing electron diagramming. So let's look at that. So there'll be some additional calculations involving energy, frequency, and wavelength. This is on the separate section. All right. Again, those equations and constants will be provided. You need to know how to do them. There'll be a calculation problem involving the transition of electron from one energy level to another energy level. You'll need the Bohr-Rydberg equation for that. Again, that will be on the exam. There'll be a calculation problem involving the de Broglie wavelength. Again, that equation will be on the exam. Make sure you know how to use it. And then finally, this is where a majority of the points are in this section, diagramming the electron structure of various elements, either by quantum number diagramming, there'll be one of those, orbital notation, there'll be one of those, or electron configuration, both methods, the regular method and the noble gas method. There'll be several of those, all right, several. Study your notes, assignments, handouts, and your review assignments. All right, so you had the Unit 3-1 exam review, and you had that additional review that you picked up today, actually. I strongly suggest you do that. That would be great additional practice in regards to preparing for this test. All right, like I said, this is a big one. There's a lot to remember. All right, you absolutely need to know the diagonal rule, especially when you're doing these electron configurations, all right? You have to have committed it to memory, which means you either need to be able to reproduce the diagonal rule on your exam, or, again, if you can just see it on the periodic table, it's there. Remember, the diagonal rule is laid out. That's how the periodic table is laid out. Left to right, top to bottom, by the diagonal rule, okay, by the order that the orbitals are filled. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p. Not too bad for an old man, is it? All right. Make sure you know that. All equations and constants will be provided. You may not use the diagonal rule. I just said that as a guide. You will get a clean periodic table and a calculator. That's all you get. So, this is a big one, folks. I hope you're prepared for this one. All right? This is not like Unit 1, where we're doing, measuring and, properties of matter. This is a whole nother ball game now. So, I hope you're ready to step up your game. All right? So here's hoping for a great one tomorrow for you. So until then, stay safe, be focused, study hard. Man, do I mean that. I really mean that. And be ready for this exam tomorrow. You're ready for it. You won't have any problem with it. All right? So until then, take care, everyone, and I'll see you tomorrow. So long.